Okay, so today we're going to be looking at graphing cubic functions. Our goal for the day says, I can graph cubic functions. Awesome! So here we're going to start off with our parent function. The parent function is f of x is equal to x cubed. I have me a table set up right here, so to fill in my table, I'm going to go find f of negative 2. So that means we're going to plug in negative 2 into my equation where the x was. Negative 2 here. So negative 2 to the third power is negative 8. And we do that for each one of these going down the table. F of negative 1 means I'm going to do negative 1 to the third power. Negative 1 times negative 1 times negative 1 gives me a negative 1. I'm going to go through and plug in f of 0, 0 to the third power. It doesn't matter how many times you multiply 0. I do believe it's still 0. 1 is still going to be 1, and 2 is going to be my 8. It's just going to have a positive 8. Oh, that's an ugly positive 8. Positive 8. There we go. Much better. Now that I have these here, I need to go in and graph them. So let's go graph my points. So I'm going to graph these using a blue marker here. Let's make it a little bit bigger so we can see them on here. Alright. So I have negative 2, negative 8, negative 2, negative 8, way down here at the bottom of my graph. I have next negative 1, negative 1. That's a pretty big jump up. Next I have 0, 0. I've got 1, 1, and 2, 8. Graphs of cubic functions look like this here. Comes down, curves a little this way, and then curves down like this. That is the parent function for a cubic, so x cubed. So my domain, we start at negative infinity, and it goes to positive infinity. It's all real numbers. You'll also see that sometimes written like this, all real numbers. The range, again, is the same, negative infinity to positive infinity, or also all real numbers. Now the center. Center is also sometimes referred to as the point of inflection. That's basically where is it changing direction. Well, that's this point right here. That point right there is located at 0, 0. Okay? Our parent function of a cubic equation. So we're going to continue along. We're going to make some changes to them though and do some comparisons. So looking at this right here, we want to take and compare and see what's happening with these right here. So my parent function, I'm going to go put that one in first. I'm going to put it in blue since that's what we did the parent function with on the other graph. It's going back in exactly like it was here. And down. So my parent function, this one here is f of x equals x cubed. Okay? So now I need to do 4x cubed. I'm going to do that one in red. This one in red right here. We'll make it a little bit bigger. So if I put 0 in, that's not going to change. It's still going to be 0 here in the middle. If I put 1 in there, 4 times 1 is 4, so I go over 1 and up 4. And if I put 2, oh, that's going to be 32. That's going to be way up there, so we're just going to draw that one up that way. And then this one here will be negative 4, and then way down here. So it's going to go real steep like this. So what's happened with this function compared to the parent function? Well, it's a little skinnier and a little stretched out. Okay, a little skinnier, a little stretched out. So this one right here, the red one, is f of x equals 4x cubed. We're going to graph the next one. We'll graph it in black. So it says 1/2 of x. Well, 0 is still going to give me 0 right in the middle. Half of 1 is 1/2. Half of 8 is 4. Same thing on the other side here, negative 1/2, negative 4. So it's going to look like this. Coming down here, like so. So this one would be my f of x is equal to 1/2 x cubed. So when we multiply by a number, it's going to go through and determine how stretched out or squished or compressed that it may be. If it's between 0 and 1, the closer to 0 it gets, the more compressed it is, or it gets closer with the point of inflection. If it's a larger than 1, it's going to stretch it out, make it real skinny going up. So looking at our next example we have here, it's again a comparison. We're going to start off with our parent function. I'm going to do it in blue again. I'm going to have my 0, 0, 1, 1, 2, 8, my negative 1, negative 1, negative 2, 8, the parent function graphed here in blue. Now this next one says, hey, I'm going to take and add 3 to it. The number on the outside when it's being added like this is going to shift everything in the direction that it's given there. So with this one, the plus 3 means I'm going to go through and move it up 3 units. So everything gets moved up 3 units. 1, 2, 3. This one here, 1, 2, 3.
Good morning, teachers.
Okay, so we're moving everything up 3, then we're going to take and move up this one up 1, 2, 3 as well. This one up 1, 2, 3. So it's going to look like this right here. It's going to look exactly like the parent function, just shifted up 3 units. This one here says a minus 4, so we're going to shift everything down 3 units. So 4 units. Excuse me, 4 units here, not 3, 4. So I'm going to go down 1, 2, 3, 4. Each point, 1, 2, 3, 4. This one up here, 1, 2, 3, 4. Over here, 1, 2, 3, 4. And the other one is off the graph. So it's going to look like this right here. Just like the parent function, because nothing was being multiplied. So we have those 3 there. All of these are based off of our equation. F of x is equal to a parentheses x minus h cubed plus k. A either does a stretch or compression. I can spell compression. And a reflection if negative. The center, also known as the point of inflection, is going to be H and K. And notice since the H is inside the parentheses here, just like with our other graphs we've done in the past, the H goes to the opposite. So if it was a plus 3 in there, then it would be negative 3. If it was a minus 2, then it would be a positive 2. And that just shifts it left and right along the x-axis. Graphing cubic functions. Find our domain, our range, our center, and then graph them. Enjoy.